Hey there, everyone. Today we're on our last day of inverses. All right, we're going to look at a second property of inverses in this lesson. It says that if f of x and g of x, if these are two functions that are inverses of each other, then that means their compositions have to equal the identity function. Now, we talked about the identity function yesterday. Recall, it's just the equation y equals x. So what this is stating here is that if you were to find f composed of g of x, it needs to result in x for those to be inverses of one another. And it would also have to be true in the other direction, that g of f of x has to equal x as well. So let me give you a nice concrete example to this. So let's say we're working with the function f and it has the point of 1, 2 in it. Then that would mean that function g, if it's an inverse, it would have to have the point 2, 1, right? So I'm going to find, let's do g of f of 1 here. Okay, this is a composition g composed of f of 1. I'll start with the inner function. F of 1 means go to the function f, locate a point whose x coordinate is 1. What's its y coordinate? That would be 2 right here. Okay, so we can simplify this. We can say that this becomes g of 2, right? Now g of 2 means go to the function g, find a point whose x coordinate is 2. What's its y coordinate? It would be, in this case, 1. Okay, so that means g of 2 equals 1. So notice that in the beginning of the composition, we began by plugging 1 in, and we ended, our final output was the same number of 1. That's specifically what this property is stating between inverses. Okay? So let's use the property down here on two continuous functions, right? F of x is 2x minus 10. G of x is 1/2 x plus 5. We want to use composite functions to determine if they are in fact inverses of each other. So I'm going to, let's start with f of g of x first. Now we learned yesterday this can be simplified by substitution. We know g of x in this case is 1/2 x plus 5. In function notation, f of 1/2 x plus 5 just means go to the function f, wherever you see x, replace it with 1/2 x plus 5, right? So that would look like this. Then I can distribute the 2 here. And I get an x to result. That's what I'm looking for. If these are, in fact, inverses of each other, the property above says the composition should result in x. Okay. Now, this is not enough, though, to conclude that f and g are inverses, though, because recall that the operation of composition, it's not commutative. F of g of x does not always equal g of f of x, right? So I need to show this in the other direction just to verify. So let's go here. Okay. G of f of x would be able to be rewritten as g of 2x minus 10, which is equivalent to 1/2 multiplied by 2x minus 10 plus 5. Distribute the 1/2 there. That's going to give you x minus 5 plus 5, which also equals x. So since both of these compositions in both directions equal x, we can conclude, yes, f of x and g of x are inverses of one another. Okay. All right, now it's your turn. Go to practice 4 here. So you are given two more linear functions, you need to find their compositions. Okay, start there. And then once you get answers for each of those, make a conclusion that yes, they are function or inverses of one another,